Hello everyone and welcome back to the course. In this lesson, we will learn about actor communication in Unreal Engine. This is one of the most asked about topics by beginners, as it can be a bit confusing when you're first starting out. So we will take our time and look at each method of actor communication in its own lesson. Let's get started. Before we jump into Unreal, let's take a moment to learn about actor communication in the engine. Actor communication refers to the ability of one actor instance to share information with one or more actor instances in the level. Typically, actor communication is used to get information from the target actor or to trigger functionality. There are four main methods of communication available in Unreal Engine: direct communication, casting, interfaces, and event dispatchers. In this lesson, we will focus on the direct communication and casting. We will learn more about the other methods in future lessons. Direct communication is the simplest and most common method of actor communication in Unreal Engine. The working actor uses a reference to the target actor to enable communication. And by holding this reference, the working actor can get or set the value of the target actor's variables. The working actor can also call functions or custom events on the target actor. We also want to learn how blueprint references relate to the class hierarchy. So let's take a quick look. When you create a reference to a blueprint instance, the reference can be used for the blueprint class, but also for all its children. So say, for example, we have a base platform class that has two child blueprints, Platform A and Platform B. If you create a reference of class base platform, you will be able to reference all three blueprint instances. However, the opposite is not true. If you create a reference of class Platform A, you will not be able to reference Platform B or base platform. This is something to keep in mind when designing your code. Now let's jump into Unreal and see an example. And now that we're back in Unreal, let's think about an example that we can use to learn about direct communication. We already have a platform that activates when our character overlaps the volume. An easy example would be to have a separate blueprint that would activate our platform. So instead of overlapping the volume here to activate the platform, the player would overlap another blueprint which could then communicate with our platform and get started. But before we do that, let's go ahead and rearrange our hierarchy for our platform like we talked on the example before. We would want to create a separate blueprint that will act as a parent for our platform here, which then can be used for various examples for direct communication. So let's go ahead and do that now. Let's go ahead and create a new actor blueprint and name this BP_platform base. Double click to open it. And this blueprint will serve as the parent for our BP platform class. So all we need to do now is go back to our BP platform blueprint, and we will click on class settings, and all the way to the right we see that we have an option for our parent class. By default, the parent class is the actor class, but in this case we want to click on the drop-down and search for platform base. After selecting it, go ahead and compile. And you can see that now our parent class is BP platform base. So let's think about this for a little bit. if we are going to have a separate blueprint that we're going to use to activate our platform, we are basically going to mimic or copy the functionality that we have on our box overlap. In other words, our separate blueprint will want to do basically what we are already doing here. So the first thing we want to do is disconnect these two nodes here, as we don't want the player to activate the platform when they overlap the volume. The second thing we want to think about is, how do we want to activate our platform? We want our player to overlap a separate volume, which then will use the reference to our platform to set our player on to true and then call the function go forward. But we can do something a little bit better than that. Since we have a parent blueprint called BP platform base, we could actually create a custom event and a separate Boolean variable that will be used by our child blueprints, in this case BP platform. So in this case, let's go ahead and create a new custom event, and let's simply call it EV activate. This event will be called to activate our platform. We will also create a new Boolean variable, so let's go ahead and do that now. And let's simply call this one active. Let's go ahead and compile. And let's go back to our map. And just for clarity, let's go ahead and click Save All. And let's rename our BP platform to BP_platform A. Let's go back to our platform A. And now we're going to use the event activate from our parent class to call our go forward custom event here. And one way we can do that is by overriding the event. So right here under functions, you will notice there is an override drop down here. So click on that. And you'll see that we have a lot of functions or events that we can override, including the brand new custom event we created, EV activate. So go ahead and click there. And you'll see that we have a node that will be called in our child blueprint when the custom event EV activate is called on the parent class. And all we need to do here is simply set player on to true, use the 1 second delay, and call go forward. So we can simply copy these nodes and connect them to our event. Let's go ahead and compile. If we go back to our map, let's now duplicate platform A, right click, select duplicate, and let's name this one platform B. Let's double click to open platform B. And in this case, instead of using this method here, let's go ahead and disconnect for platform B. We are going to use the code that we had for event tick. So instead of connecting here, we want to make sure that we activate our platform when a specific Boolean is true. So we can make some space here. And if you recall, going back to our base blueprint here, we have a Boolean called active. We can use this Boolean on our platform B to make sure that our platform is active. So if you look under the variables here, you will not see the active variable that is part of the parent. And that is because we have a specific setting that hides those variables. So if you click on the little gears icon here, you can select Show Inherited Variables. And if you select it, you'll see that we have a bunch of variables that are now available under the Variables section that are all inherited from the parent. And now you can see that we have the variable active that comes from our parent. So if we simply drag it to the event graph and use it in a branch, and let's connect it to tick, and then connect this to our previous code, we now see that for platform B, we will immediately start checking on tick whether the platform is active or not. By default, the platform will be inactive, so we will not move. But as soon as we set this variable to active, the platform will immediately start moving. Let's go ahead and compile. And now let's go back to the bottom. And for event activate for platform B, instead of doing any of this, let's go ahead and delete that. All we need to do is set active to true. So drag active to the event graph, click set active, connect it to the event, and set this to true. Let's go ahead and compile. So let's think about this one more time before we test. Our base platform here has a custom event called event activate and has a variable called active. Then we have our platform A, which is a child order based platform that overrides our event. And once this event is overwritten, it changes the player on variable to true, waits 1 second, and calls go forward, which is the exact same code we would call when the player overlapped our local box here. And platform B, because we are using our tick code here, we simply added a simple branch with the parent variable active. And now for platform B, when we are overriding the event activate, we are simply setting the variable active to true. So notice how the same function from our parent class or event activate, can be overwritten in a child class, and you can add your own custom code. So when we're calling event activate for platform A, this code will execute. But if we call the exact same event for platform B, only this code will execute. Let's go ahead to our map and click on Save All. We are now ready to start our actual example. And now let's go ahead and create our activation blueprint. So let's create a new actor blueprint class and name this BP_activation. Let's double click to open it. And just like before, let's go ahead and add a cube and scale it. And now let's add a box collision. Now let's go ahead and compile. And just like before, let's right click on our box collision and select Add Event on Component Begin Overlap. And what we want to do here is when our player overlaps our box collision, we want to call our activation custom function on our platform, either A or B, to then activate the platform. So the first thing we want to do is we want to create a new variable that will hold the reference to our platform. So let's go ahead and click on Add Variable. And let's name this Platform Reference. And now let's click on the drop down for variable type. And in this case, let's go ahead and search for BP Platform Base. And in this case, when we hover over BP Platform Base, you'll see that we can select either an object reference, which refers to an instance of the blueprint class in the level, or a class reference. We want to make sure that we select object reference. Let's make sure that we click on the eye icon here to make the variable public, and let's simply compile. If we go back to our level, let's go ahead and drop our BP activation blueprint in the level, and let's delete our platform blueprint here, and let's drop a platform A on the left and platform B on the right. That way it'll be easier for us to see which platform is which. And for either one, let's move the end location somewhere else. There you go. Now we have both end locations in a separate place. And we have our BP activation blueprint here that will activate both of these platforms. So right now, with the BP activation blueprint selected, you'll see that we have a variable called platform reference. And if I click on the drop down, notice that we have both platform A and B available. We can select either one of these platforms to activate. And the reason for that is because if we go back to our activation blueprint, the class of our reference is BP Platform Base, which is the parent of both platforms. If we were to change this to say platform A, object reference, and we go ahead and compile, once we go back to our map and click on the drop down, notice that we only have platform A available. So that is the difference between creating a reference to a child blueprint class and a parent blueprint class. And obviously this works for all levels of the hierarchy. If we were to set this variable to an actor class, we would basically be able to select almost any blueprint in the level. So let's go back and change this to the base class and compile. Let's go back to our map. And in this case, let's use the eyedropper tool here. Click here. And notice that as I'm moving my mouse, we have a little cross icon here, basically telling us that we cannot select whatever our mouse is hovering over. However, if I put my mouse over our platform A, you can see that the eyedropper icon appears, and the same thing for platform B. So let's go ahead and just select platform A here. So you can see we have it added here. And if we go back to our BP activation, all we need to do now is the same logic that we had before on platform A. So if we go back here on platform A, we simply want to call event activate. So let's go back to our BP activation, drag our platform reference to our event graph, select get platform reference, and then we'll drag and search for EV activate. And you can see that we have it right here. Go ahead and select it. And all we need to do now is connect it. If we go ahead and compile, let's go back to our map. And now if we click on play, before we step on our activation blueprint here, let's walk over our platform A to see if we can actually activate it. Okay, so you can see, even though we're overlapping our box here, the platform is not being activated. So now let's go ahead and overlap our activation blueprint. And now you see that our platform A has been activated. Let's go ahead and stop. And now let's do the same exercise but select platform B. So we can click here the drop down and select platform B, or we can use the eyedropper tool, doesn't really matter. And let's simply go ahead and again click on play. And this time let's tap again on the activation platform here. And notice that as soon as we do that, our platform B is activated. Let's go ahead and stop. And again, take a second here to understand what we're actually doing. Notice how simple this is. Our BP activation blueprint has a variable that holds a reference to an instance in our level. We set that instance inside the editor either by using a drop-down or the eyedropper tool, and all we're doing is dragging and dropping and calling a custom event that is available in the platform base. As you can see there, it says target BP platform base, and then that event is then being overwritten by all of the child blueprints, and each one has separate code. So our BP activation only has to call this function once for the parent class, and we could keep adding as many different platform types as we wanted, and as long as we use the same method of overriding this custom event, our blueprint here will work. For this next example, we are going to be using an array. So as you noticed here, we have one single reference for a platform, and whatever we have referenced here will be activated. But what if we wanted to activate both platforms at the same time? Well, we could duplicate this variable and add another variable and have one reference for each platform, or we can simply convert this value to an array. So let's go back to our BP activation blueprint, and let's actually create a new variable. So let's right click to platform reference, select duplicate, and in this case let's just call this platform list, and let's go to our variable type and click on the icon here and select array. And now instead of simply using the platform reference, we are going to use the platform list. So let's go ahead and drop it in our event graph, click on get, And just like before, we're going to use a for each loop. And let's go ahead and connect it here. And instead of using our reference, we're simply going to drag from array element, which by the way is the exact same thing as dragging from this single reference, and look for EV activate. Let's go ahead and compile. And now we're doing the exact same communication, except that we are communicating directly with every single element in our array. One more thing we would add here is we want this to happen only once. So it'll be nice if we ensure that if the player overlaps this trigger, the activation happens only once. And we can do that by using a do once node. So let's go ahead and add it here. Now let's go ahead and compile, go back to our map. Now let's go ahead and add our references to our platform list. Click on the plus sign here. Let's use the eyedropper tool. Select platform A, click on the plus sign again, and let's select platform B. And as you can see now, we have an array of platform A and B. And if we click on play, let's go ahead and step on our activation blueprint. You can see that now both platforms have been activated. And now let's take this a little bit further and add a few more platforms to our level. And now let's say that yet again we wanted to activate all of these platforms. So we would have to then manually add each individual instance here. There is another way that you can do that programmatically though, and let's go ahead and explore that now. Let's go back to our BP activation blueprint, and here let's scroll all the way up to event begin play and drag from here and search for get all actors of class. Go ahead and select it. And this node will simply scan our entire scene looking for blueprints of a specific class and return, as you can see, an array of actors. So if we select the actor class here and specify platform base, we can now set our platform list to this array. So we could drag platform list all the way to our event graph, select set, and notice that in this case we are setting the entire array. Notice that the two icons are exactly the same, so we can simply connect it, and now we are populating our platform list with all of our references to all of the platforms on begin play. So now if we go ahead and compile, go back to our map, and we know that manually we have only platform A and B, these two referenced here. We don't have these two referenced at all. If we click on play, and let's step on our activation blueprint, you'll notice that now all of our platforms are being activated. Let's go ahead and stop. Let's go back to our BP activation blueprint. One thing I do want to mention here is this is a very expensive node, so you don't want to use this too much at runtime. In this example, we're using this once on begin play and grabbing all of the reference to our platforms in the level. And then when we overlap, we are doing this once, we are grabbing the same platform list that we populated on begin play, and then we're simply cycling through all the events and activating the platforms. Now let's look at one more example to make it a little bit more useful. Say that you have many of these platforms in your level. However, you want to specify specific platforms for your activation blueprint. You could either do it all manually, as we were doing it before, or you could still use the programmatic way by getting all of the platforms on begin play. However, you may want to filter the platforms. And one way to do that is to use actor tags. So if you select any actor blueprint in your level, let's go ahead and select this one here. If you search for tag right here on the search box, you'll notice that we have under actor, we have tags. And if you click on the plus sign here, you can add any tag for that actor that can be used later as an identifier. So let's go ahead and say that we have different rooms in our level and we only want to activate the platforms that are in room 1. So we could simply add a tag of room 1 to this platform here. And let's go ahead and do it for this one as well here. And for these two, let's add room 2. And now if we go back to our BP activation blueprint here, if we go up here, what we can do is we can have a platform list variable that will select all of the platforms. But then right here, when we are going through our list, we could then look for a specific tag, and only if the tag is available do we want to activate our platform. So let's go ahead and see how we can do that. Let's make some space here, and we'll drag from our array element and search for has tag. And you'll notice that we have a node called actor has tag. Let's go ahead and select it. And you can put whatever tag you want here. So in this case, let's do room 1. And you'll notice that the return is a Boolean. So we can use a branch here. So notice what we're doing here. We are still going through every single platform on our level. But before we do anything, we are checking whether that specific platform has a tag, in this case room 1, and only if this is true, we are now activating this. So let's go ahead and compile. Let's go back to our map. And now let's go ahead and click on play and step on our platform. And as you can see, only the 2 platforms with the correct tag are activated. Let's go ahead and stop. And one more thing we can do is go back to our blueprint. We can right click on the tag pin here and promote this to a variable. And let's make this public. And now if we go back to our map, we see that if we select our activation blueprint, let's go ahead and clear our search. We have not only a platform list that will be populated automatically, but we have a tag variable that we can set here in our level to decide which platforms to activate. So if I simply change this to room 2 and click on play, and we step on our platform, notice that only the platforms with the tag room 2 are activated. Let's go ahead and stop. As you can see here, with very simple code, we can start adding a lot of customization to our blueprints. One single blueprint can now communicate with many different other blueprints in the level by setting the correct references here, either as a single reference or an array, and we can further filter those selections by using an actor tag. Now let's take a moment to learn about casting. Casting is a communication method where you take a reference to an instance of an actor and try to convert it to a different class. If this conversion is successful, then you can use direct communication to access its information and functionality. So for example, we could use an overlap event from a box volume to get a reference to the overlapped actor, and then try to cast that actor reference to a different actor class. In other words, we are basically asking, is this actor's class X? If so, we can then use the new reference to access that class's data and functionality. Now let's go back to Unreal and see an example. And now that we learned more about casting, let's think about how we can incorporate casting into our example. So if we go back to our BP activation blueprint, let's go ahead and click. We'll notice here that right now, we are simply triggering our code as soon as our player overlaps the trigger. However, we're not doing any checks to make sure that the player is the one overlapping. We're simply saying as soon as this event is triggered, we are executing our code. But what if we had NPCs in our game and they will be roaming around? There is a chance that an NPC could overlap our trigger and then immediately activate our platforms. So we want to make sure that only the player can activate our platforms. And one of the ways we can do that is by using the other actor object that comes bundled with the event. See, every time this event triggers, you got all of this information that is available for us to use. And you can see here we have a pin called other actor. This is the actor that actually overlapped our box. However, this is an actor object reference. So we could check if this was our character by doing something like this. We could try to get the class of the other actor. Then we could use an equal node and add our third person character class here. And then with this Boolean here, we could have a branch. This way we could get the class of the actor and say if the class of the other actor is equal to our third person character, then go ahead and execute. However, this is not the ideal way. A better way would be to use casting. So let's go ahead and make some space here. And we can drag from other actor and simply search for cast. And now we'll do the class name, which is third person character, and we'll select it. And as you can see, this node is grabbing an object reference, which comes from other actor, and is saying, can we convert this actor into a BP third person character? And if the conversion is successful, we will execute all the code that follows this execution pin. But if it's not successful or the cast fails, then we will execute this pin. So let's go ahead and connect it here. Let's go ahead and compile. And as you can see, now we're doing a simple check. Only the player character is allowed to activate our platform. So if we go back to our level and we click on play, if we step on our activation blueprint, you'll see that our platforms are indeed being activated because the casting succeeded. Let's go ahead and stop and go back to our blueprint here. You'll notice also that the casting node has a pin called as BP third person character. This is actually a reference to our player character. So if you drag from here, you'll be able to grab any data from our player or set any data from our player. It's very similar to the way we're doing it here. So what if we wanted to have the platform activate only if the player had a key? Well, we could do that by simply adding a Boolean to our player character and then checking whether the Boolean is true. So let's go ahead and do that. Let's go back to our map, click on third person, click on blueprints, and let's go ahead and open third person character. And all we're going to do here is click on variables, and let's name this has key. Let's go ahead and compile. And in this scenario, we are going to pretend that we have one way of setting this Boolean from false to true. So if we go back to our activation here, now we can drag from this pin and search for has key. And you can see that we can either get or set this value. Let's go ahead and get the value. And now we can use this in a branch. Let's go ahead and make some space. And as you can see, we are now overlapping the volume. We are casting to our third person character. And if that succeeds, then we're saying fine. Does the player have a key? And only if the player has a key, we are then executing our code and activating our platforms. So now if we click on compile and go back to our map, we're gonna hit on play. And let's step on our platform one more time. And nothing happens. That is because we don't have a key. Let's go ahead and stop. Let's go back to our third person character here. We're going to make has key true. Go back to our map, click on play, and let's step on the platform one last time. And as you can see, the platforms are activated once again. So as you can see, casting is very similar to direct communication because all we're doing with casting is converting one object from one class to another class, and then that reference can be used in the same manner as direct communication. The same thing could happen here. If our platform list was of type actor, we could then cast from here to our platform class BP platform base, and if that was successful, we could then execute the code as you see here, and it would work the same way. Hopefully you can see how casting can be extremely useful when using direct communication with our blueprints. Now let's do a quick recap. Actor communication refers to the ability of one actor instance to share information with one or more actor instances in the level. In direct communication, the working actor uses a reference to the target actor to enable that communication. And by holding that reference, the working actor can get or set the value of the target actor's variables, as well as call functions and events. And when you create a reference to a blueprint instance, that reference can be used for the blueprint class, but also for all its children. If you want to practice what we learned, think of 3 examples where you would use casting. And that's all for this lesson. Thank you so much for watching, and I'll see you in the next one.